The streaming started, Atul.
Okay, ma'am, I'm just starting. Okay, so let us start the session. My voice is clear to everyone?
Yes.
Okay, so this is the first session on week 6. So I just want to know, have you gone through the concepts? I mean, is there any instructor session on week 6 happened?
Yesterday, yes.
Okay, okay, good. So let me share my entire screen. Okay, so if you have any doubt in this, any activity, you can ask. Okay, so in week 6, what are the concepts covered is so in week 5, you already know what is a linear transformation. Okay, and what are the two properties that are important in order to be a mapping or linear transformation. Okay, you know that. Now in week 6, uh, we will understand more properties of a linear transformation. Suppose what is the kernel of a linear transformation. Okay, linear transformation also have a kernel. A linear transformation has a matrix, okay, that can represent that linear transformation for a particular ordered basis of domain and codomain. Then what is basis of a codomain? What is ordered basis? Okay, and then what is the image space and corresponding kernel space, and also yeah. So that's all. The finding basis of kernel and image. So this is all, and matrix. This is in week 6. In week 7, I guess, yeah, week 7 is different. Okay. Yeah, so in week 6, the linear transformation will be finished. So just before starting, I just want to suppose this is a linear transformation T from uh, R2 to R2. Okay, so let's take an example. Suppose we take a vector in R2, and we take this linear this apply T here, this mapping T, and we got suppose x plus y comma x minus y. Okay, so is this a linear transformation? I mean, will this satisfy these two property? So will this satisfy this two property? So let's check. So this is x1 y1. So this is x1 plus y1 comma x1 minus y1. Okay, and this will be x2 minus y2 comma x2 sorry x2 plus y2 and x2 minus y2. Okay, and when we add these two, this will be x1 plus y1 plus x2 plus y2. So this is exactly this when we add these two terms, and then x1 minus y1 minus x2 plus y2. Okay, so when we subtract these two, we will get x1 plus x2 minus y1 minus y2. This is not okay. This is not equal to this. Am I right? Sorry, here I it is addition, right? It is addition. So x1 minus y1 plus x2 minus y2. Okay, so then I think now it is equal. So yeah, this is a linear transformation. I think I have subtracted these two, but this is addition. Okay, so this is a linear transformation. Uh, so if I want to know uh, what is the kernel, how will I find? What will be my approach? What is kernel? So what is kernel in general? I mean, this for this linear transformation. The definition.
Null space.
Null space. Okay, basically, all those vectors in R2 which are mapping to zero vector, right? I mean, all those x and y, okay, which are mapping to zero. So what I'll do? I'll this the zero and x minus y equals to zero. So when I solve this system for x and y, what will I get? Kernel, right?
Yeah.
Okay, and when I suppose x plus y equals to general point A and x minus y is equal to general point B. For this system, uh, I will get the image space. I mean all the points. Okay, or not go this way. Uh, there are other ways also. You can find a linear transformation matrix. Okay, linear transformation matrix, and now uh, you can reduce it. Okay, reduce it in RREF. Okay, so what this matrix is corresponding to this mapping, and when you reduce it, you will get a different matrix row reduction after row reduction. Then you can find the nullity of that matrix A. Okay, that will be the dimension of the kernel. And when you get the pivot columns, okay, there is a leading entry. The pivot columns will span the image space. Okay, basically the pivot columns would be the basis for image space. Okay, so image space is in this codomain, and kernel is in domain. Okay, so this is some basic thing. So basically in this week, you know I mean, you have to understand what is ordered basis and what is kernel. So you know now. I mean, you have some idea because you already must have gone through the lectures or the instructor session. I'm just revising. Okay, and basis.
For finding the image, do we have to equate it to anything like the individual expressions?
No. We have to have the linear transformation matrix for finding
Yeah. So
image.
if I do reduce the transformation matrix,
Hmm.
what do I do then?
Then you will get the columns, right? The pivot
Yeah.
columns.
Yeah.
And those pivot columns will be the basis for image space. So now you have the basis of a vector space, right? Then you have
Yes.
the vector space as well.
Okay.
Okay. Now you can ask questions if you want to ask in from activity 1. Okay. If any of you have any doubt from week 6, you can ask. Otherwise, I'll just take this solve with us. Okay, I'll solve with us 1, solve with us 2. Okay, and reflect with us. Okay, these assignments I will solve with you.
But the solvers already have elaborate solutions. Why don't you do the practice assignment instead?
Okay, then
So can you
yeah.
do question number 7, sir, of
Okay.
6.1 only?
Okay. Question number 7, right?
Yes.
So this is choose the correct option. So which option you have doubt?
So mainly in first and
Okay, let's
third.
take the.
Third, yeah.
Okay, let's. If the identity matrix of order 2, okay, is the matrix representation of the linear transformation R2 to R2. Okay, so with respect to the standard order basis for both the domain and codomain. So what do you mean by this ordered basis? Do you know?
So like for R2, what I can
Because yeah,
guess,
so
ordered
standard,
basis.
yeah, so standard basis, 1001. Right? This is for R2. I mean vector
Yes.
10 and 01.
Like
A standard
0,
basis,
1.
but yeah, but a standard basis, ordered basis represent that. So if we are taking the standard basis, okay, in this particular order, like 1001, and this set is an ordered set of bases. Okay, that's we call ordered basis. And why it is ordered? Because if we change this, suppose we take another basis, suppose 1 1 and 1 2. This is also independent vectors in R2, so it will form a basis, right? 1 1 and 1 2. Is that true or not? So if you take these set of vectors for bases, then this the matrix would be different. Okay, the linear transformation matrix would be different. Okay, so that's why we call it ordered basis. Even the order will be changed, then the matrix will be changed. Okay, then it is also so it is saying both for domain and codomain. Then it is also metric representation of T with respect to any other basis beta for both the domain and codomain. Okay, so identity matrix is the matrix. Then what we can get from here? Identity matrix, that means if we have any vector x, okay, in domain, then we multiply this this matrix to the left, then we get another vector. Okay, that's that vector would be in codomain. Okay, so because A is identity matrix, so x would not be changed, x will be x, right? Are you getting my point, what I'm saying?
So like you're multiplying it to some other vector, this identity
Yeah, so
matrix.
because
So you will get the
T is
vector again. Yeah.
R2 to R2. Okay, and we have the identity matrix as the linear transformation matrix with respect to the standard order basis for domain and codomain. So what is identity matrix? So basically, so identity matrix is A, right? I'm taking A. So I'm taking any vector from R2, suppose x1, x comma y. Okay, this is vector in R2, and I'm applying T here, and what I'm getting x and y itself, because after multiplying with a x y, I'm getting X and Y itself, because A is an identity matrix. Is that clear?
Yes, this I have understood, sir. Yeah. This part I have understood.
Okay.
After this, like
This is
after
2
taking
cross 2.
another basis, then how we are going to get this identity matrix again for the representation of linear transformation.
Some vector xy. Okay, so this is actually basic. So this is how we actually, this matrix is transforming this vector in this space. Okay, so because now you have the linear transformation, right? What is linear transformation? The identity transformation, right? Is that clear or not? At this part, I mean, you
Yes,
have
sir.
the
Yeah.
linear transformation, which is an identity transformation.
Yes, sir.
Okay, now because you have T, then you can answer, then it is also a metric representation of T uh, with respect to any other basis beta for both the domain and codomain. Yes, this is true, because uh, basically identity transformation matrix would come out. Okay, the vectors would not be changed.
So what does it mean for both domain and codomain? What are they trying to tell?
Uh, because this is domain, okay, and this is codomain, both are R2, so they because they are both vector space, because this mapping is from one vector space to another vector space, so both the vector space would have the domain, would have the basis, right? So that's what it is saying, basis for domain and codomain. Okay, so basically from the above information, this identity matrix of order 2, we first find out the T. Okay, and T is xy. Okay, no change. So this is possible only when the matrix is always identity matrix, right?
So they are saying transformation being the same. If they change the domain and codomain, will the results be same? Is that what they're asking?
Yes,
Okay.
because transformation is identity.
Mhm.
The matrix is identity. That's why only. If suppose this is not a identity matrix, the linear transformation, and for the standard basis, okay, and then if we change the basis, the matrix would also change. Okay, that is the other case, like the matrix that would be changed will be a similar matrix. Okay, so what is a similar matrix? It I think come in the first lecture of the week 7, I guess. Let me confirm. Yeah, equivalence of a similarity matrices. So that matrices would be similar but different. Okay, similar metrics are different in, you know, if you see two matrices, entries would be different, but they would be following some pattern or property. That's why we call them similar matrices. Okay, they will be behaving like the same. Okay.
And then for option two, sir, like if
Hmm.
T is given as an isomorphism between two vector spaces,
Hmm.
and A is also like with the matrix representation of T. So, if A is like reduced to a row echelon form, I'm
Hmm.
just thinking of it.
Hmm.
Like if A is reduced to a row echelon form, then whatever will be the nullity of the reduced row echelon form, that will be the same will be for A also.
Yes. Yes. Yes.
So we can think of it like since it is isomorphism, then we can say like it is onto, and when it is onto, then nullity is going to be zero. So I think this is also correct. Okay. So
Yeah.
can you
Yeah.
explain option three, sir?
Okay,
Third
okay.
option.
I'm going to option 3, but let me first read this option 7. T be an
Okay.
isomorphism between two vector space and A be the matrix representation of T with respect to some basis. Then the nullity of A is 0. Yeah, so because isomorphism means 1 1 and onto. So, so there actually we will get some basis. Uh, Nullity is 0.
Yeah, nullity needs to be 0 for 1, 1 to be true, right?
Oh, I mean zero. I guess I was thinking the dimension of, but yeah, dimension is also, but because it is 1 1, so 1 1 means the kernel is zero, only zero vector. Okay, so that's why it is just a straightforward actually. Okay. Everybody is fine with the option two.
Yes.
Okay. Option 3, if A is 0 0 1 0 1 is a matrix representation of T with respect to the standard order basis for both domain and codomain. Okay. Then matrix representation T of T with respect to some same basis will also be A. Okay, so let's check. Let me take the screenshot first. So in the third option, here this option I am talking about, A is given here for R2 for the standard basis. Okay, so then the matrix representation of T of T. So what is T of T? Let's try to. So for T, we will multiply by A. Okay, in X. Okay, if X is a vector, then this would be AX. Okay, so, and if it is T of T, then we will multiply again by A. So it will be T of X would be A square X. Is that clear? Okay, so this is the matrix A square. A square is the matrix for this. Then it is just saying with respect to some same basis will also be A. The matrix representation with respect to the same basis will also be. So let's check the A square. What is A square? If A square is A, then we are fine. So here we will get 0. Okay, and 0 because first row is 0, so first row here will also be 0, and second row is 0 1, so it is 1. Clearly it is same, right? So A square is A, so this is also AX. Okay, so yes, same, this is also true. Understood, everyone? Any doubt
Yeah.
in this? Yeah. Okay, any other question?
So,
Hmm.
so like T of T, you have found out directly by putting the T of X value. Like we used to like this representation. I've not.
So T of T. Okay, so basically, so this T of T means this is okay, and so what is inside T of X? AX, right?
Yes.
Okay, and then this is A times A of X, which is A square X. And what is A square? This is AX. So matrix is same. Okay, because A square is A. This is just we checked.
So like, can we look at it like in another way? Because like, can you scroll up? Can you scroll up?
Hmm.
Yes. Like it is given that A is a matrix representation for
Hmm.
this transformation
Hmm.
with respect to standard ordered basis of R2.
Hmm. Hmm.
Like if you think of it line by line according to the question only,
Okay, okay.
can according to that, I am just asking, can we represent it using another for the same basis? Can we get the transformation for this particular R2 to R2? Can we get
Yes,
it
yes, 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 we can get.
directly?
Yeah. So see, it's because the same basis, that's why I did this way. Otherwise, suppose
Okay.
matrix
Okay.
is given, so we are trying to find the linear transformation because matrix is known. That means we know we know the basis as well, right? So we will find the
Yes.
transformation as well. So suppose we will take any vector x and y, okay, and then we'll just multiply by this matrix A 0 0 0 1. We are trying to find the mapping for this, okay, x and y vector. So what it would be? It would be 0 y. Okay, so linear transformation is x comma y
This is going to be okay. Fine.
comma y. This is the linear transformation,
So
and
this will also work for T of T also, because if we put T of
yes,
xy for
yeah,
T, then
yes,
again we are
yeah.
going to get okay.
So again, if you apply again t on 0 comma y, we'll get 0 comma y. Okay, so you are
Okay, fine.
getting.
Yes, sir. So question number 10 for this.
Question number 10. If T R2 to R2 is a linear transformation which is both 1 1 and on 2, then T inverse is also a linear transformation. Okay. So first option is saying if it is a linear transformation which is both 1 1 and on 2. So 1 1 on 2 means, and it is asking about the T inverse. So 1 1 means nullity is 0, right?
Yes, sir.
Nullity is 0 means AX equals to AX equals to 0 has unique solution, right? And unique solution means only 0 0 0 is the solution. That means A is invertible. Okay, so what is the property? So when a transformation is isomorphism, okay, 1 1 and on 2, oh, okay, then that is means that they are basically same vector space to same vector space. Okay, just forget about this. The isomorphism is invertible. Okay, this mapping is invertible because it is both 1 1 and t onto. If you are finding it hard to understand why the first option is correct, you can relate it to the 12th class concept. Okay, where the inverse functions are the functions where they are 1 1 and onto, right? Both way mapping. We can call it both way mapping. Okay, this is possible only when the function is 1 1 and on 2. Is it clear or not?
So actually, one thing I can relate is that T is the transformation from R2 to R2.
Mm.
Then T inverse is going to be from R2 to R2 only, because the
Yes,
codomain is going to be the domain, and the
yes,
domain is going to be the codomain for T inverse.
yes, yes.
But
But it
but
is 1
like
1 and on 2. So see, this is very
okay,
important. This is 1 1 and suppose this is a R2, okay, a plane, and this is also R2 plane. Okay, then suppose this vector is mapping to this vector, and this vector is mapping to this vector. Okay, so but all the vector are mapping to all the vector of this, okay, but different, okay, suppose. So and exactly one, okay, no, like there are two vectors which are mapping to the same vector or zero vector, okay. So this is not the case here because it is 1 1, and it is onto means all the vector on what is onto, all the vectors of this R2 are able to cover. So all the vectors are able to cover without actually having the many to one relationship. That is possible only when it is it is 1 1, right?
yes, sir. Okay, sir. Understood. Yeah.
So that because it is on one, then we can actually define a mapping backward also. Okay, so whatever is the mapping from this x comma y to suppose 2x comma 2y. Okay, so is it 1 1 or not, this mapping? Where is can you check why it is 1 1 or not? Yes or no? Very simple. Just put 2y is equal to 0. This is implying x y are 0 0, right? So basically this is 0 only when x and y are 0. That means 1 1, right? This is 1 1. Is it on 2? Is it on 2 or not? So for that we'll just take general point 2y equals to a and b. And so is the solution for a possible? Yes, it is 2 times x. So whatever is the x, I'll just twice and I'll get a. So basically AB is a general point of R2 and I will be able to get if I have x and y. Okay, that means it is onto as well. So because it is 1 1 and onto, so we can define a backward mapping as well, which will take the vectors from here and map to map to this direction. And what will be that transformation? If we suppose the vectors from the codomain, suppose a comma b, and it will map to the domain a by 2 and b by 2. Is that clear?
Yes, sir.
Okay, so that's why we will have a inverse. So transformation for this sorry, the matrix for this transformation would be a inverse, and if a is the matrix for the above transformation. And any other option in this question?
No, sir. Only the first question, rest of the question I've understood.
Okay. Okay, so if you want to ask any question from the activities, you can ask. Otherwise, I will just start the practice assignment submodies. And if you want me to discuss the solve with us, because there I will be explaining the concepts as well, because concepts are given. That is fine for me. Okay. Otherwise, this is fine. Practice assignment. And if you guys haven't solved the activities, tell me just. Okay, raise your hand. Okay, okay. Raise your hand who haven't solved the activities, because then I will be solving activities together in this session. So raise your hand who haven't solved the activities. I mean, I'm talking about all the activities question. And the rest of you have solved all the questions of the activities. Okay.
No, sir. I haven't solved the activities question. If I have a doubt, I will ask in the next session.
Okay, that is okay. I'm just saying for this session. Uh, I mean, if you guys are solving by yourself, then should we end the session now, or I should solve some questions with you? That's what I'm saying, asking.
Sir, can I solve myself first, and can I ask in the next session
Yeah,
about my doubt?
yeah, that will be actually good. That
Yes,
would
sir.
be good.
Yes, sir. Okay, thank you, sir.
Okay, so I just realized this activity question solving is not a good idea, because you should try then first, okay, and then know the solution. Okay, so this is not a practice assignment. I can solve with you. Okay, I'll just give you one problem, solve all of you, and after that After 5 minutes or something, we'll discuss the solution. Okay, is it fine? Just raise your hand if it is fine. Sorry, raise your hand or give me a thumbs up. Yeah, all of you. Okay, most of you are not responding to anything. You can actually tell me what you want from this session. Okay, so practice assignment week 6. Okay. Question number 1. So all of you, just take 5 minutes and solve this question, and after 5 minutes, I will discuss. So taking the screenshot. Okay, guys, this is a important question. Okay, so it will take time. I'm giving you more time for this question. Okay, because every option is a question in itself. Okay, so should we discuss the question answer now? Anyone wants more time? Should I discuss? Yes or no? Anyone?
Yes, sir.
Okay. So the first option, there exists a linear transformation T R2 to R2 such that T of 2 3 is this, and T of 1 comma minus 1 is this, and T of, so basically 3 we have given, okay, so or 3 vectors in R2. So is it a linear transformation? How do we check? I mean, has anyone solved this first option? No one? No one has attempted this. I mean, got the correct. Okay, so now let's discuss the solution for this. So we have these 3 vectors. So we will try to find the domain of the basis for the domain. Okay, so we have these 3 vectors. Okay, so we'll take any 2 vectors which are independent. Okay, so basically, and so we will just take any two. Suppose these two are independent, and then just find the definition of the T, and then verify from the third. And if it is, then it is a linear transformation. Okay. Strategy, has anyone done this way? And nobody is responding. What should I do? And I'm not sure whether you are here or not. Okay, I'm just writing the solution. Okay, then. So, so for this, I'm taking this 2, 3, and 1 comma minus 1 as the basis for the domain. Okay. So I'll take any general point x comma y and try to write some a times or 2 comma 3. Okay, a times 2 comma 3 plus b times 1 comma minus 1. I'm taking these two. Okay, and then I will just try to find this coefficient a and b. Okay, that's it. Then what I do, I'll just apply that linear transformation T on x comma y. Okay, then I will get here a times T of 2 3 plus b times T of 1 comma minus 1. Okay, because T of 2 3 is given, and T of minus 1 comma minus 1 is given, and because I found the a and b from here, so a is also known, b is also known. So then this linear transformation will be known. Once I have the definition, I'll just put that point x comma y as 4 comma 1 and check whether it is 1 0 or not. If it is, then I will just mark this one. So this is the strategy. Okay, so let's do 2a plus b comma 3a minus b. Okay, this is x and y. So basically 2a plus b equals to x. So here b is x minus 2a. Put this in this equation where 3a minus b equals to y. In place of b, I will write x minus 2a. is y. So here I will get 3a plus 2a, that is 5a. 5 equals to y plus x. So a is equal to x plus y upon 5. This is a. And what is b? B would be x minus 2 times x plus y upon 5. Okay, so this would be 5x minus 2x minus 2y upon 5, which is 3x minus 2y upon 5. This is b. Okay, so I have b and a, so I will just put in this equation. Okay. Okay, and then I have a and b, and t of 2 3 is given, which is 1 comma 2. So 1 comma 2 x plus y divided by 5, 1 comma 2. And second is 3x minus 2y upon 5 times t of 1 comma minus 1 is 1 comma minus 1 itself. So 1 comma minus 1. This is t of xy, which is given. Okay. Now put this point 4 comma 1 here. So when we put x and 4 1, so it is 1, and so it is 1 comma 2 plus and 4 1 here. So 12 minus 2, that is 10 divided by 5, which is 2. So 2 times this, so 2 comma minus 2. Okay, and this would be 3 comma 0. Is that clear? What is 2 comma 1? We are checking for 2 comma 1. So oh sorry, it is 4 comma 1. Okay, 4 comma 1. Okay, so 4 comma 1 also, yeah, we have checked for 4 comma 1. So, yeah, it is right. It is 3 comma 0. But in the question it is given 1 comma 0. That's why this option is not correct. Is this clear? Clear, everyone? Yes or no? For those it is clear, raise your hand. Okay. I mean, for rest of them, it is not clear. So Neha, what is your doubt in this? Anuradha, Neha, and Parik. Okay, so I am guessing, and you guys haven't actually gone through because week 5 deadline is not over yet. So we will meet on Saturday, I guess. Okay, it is enough. And by then, please watch the instructor session and be prepared for the questions. At least attempt. You may leave the session. Yeah, Pradeep, you want to ask anything?
Yeah, Atul, I had a few doubts on the quiz one paper. If you have nothing else to discuss, can you take them up now?
Yes. Yes.
Okay.
It is,
So, do you have the question paper with you? Can you open that up once? I mean,
Oh,
I have doubts in. So there were three questions related to subspaces, right?
mhm.
They were asking about the dimension of the subspaces. If possible, could you walk me through the first one and the third one? I got both of them wrong.
Okay. So,
I can mention the question numbers exactly if you want. If you open the paper, it will be easier for you.
okay. I'm just finding the paper and then opening it. Wait a minute. Okay. So, question paper is here. Quiz. Yeah. Which question?
Yeah, so question number, uh, just
I mean, subspace is one. What you are telling?
subspaces, there were three questions, right? So 121 to 123. Can you just help me with question 121 and 123? Those two questions. The first one and the third.
Okay. Okay. Just wait a minute. This is not related to subspace. Okay.
No,
This
not
is
this.
not this one. Question three. Not this one,
Not
right?
this. Not this.
Question
No.
four.
No, not this.
Okay. Five, six, seven. I think this one.
Yes, this seven. Seven, correct.
Yes.
So seven number. So 7A and 7C as per your paper. So both of
Okay.
those I got incorrect. I was not sure how to solve them.
Okay. So W1 is AX equal to 0, where A is an invertible matrix. Okay. So A is invertible.
So
That means
the determinant. I mean, you will have a non-zero determinant.
non-zero determinant. That means uh, dimension for this is n, right?
Okay. Yes, and
Okay. And other one W3, right?
yes, the W3 is a set of all two symmetric matrices.
Yeah. So 2 by 2 symmetric matrices. Then uh, because this is symmetric matrix, yeah. So this is a good question. So symmetric matrices. So A. What are symmetric matrices?
So A transpose equals A.
Yeah. So this transpose should equals to A, which is equal to
A, B, C,
A,
D.
B, C, D. Okay. And here we know A is equals to A, but B is equals to C. Okay. From here, and D is same, but B is equals to C again. Okay. So B is equals to C here, right?
Right.
Yeah. So what is the dimension?
So dimension
B.
should be
Yeah.
2, right, for this?
No, B. One of them actually we have to know, right, from B, because here we know one of the two is independent, right? Suppose if C is independent, then B is dependent, and if B is independent, then C is dependent, right?
I'm sorry, I
I
did
mean,
not understand this.
if I know the value of B, I know the value of C, right, as well.
Right, right. They'll be same, the
Yeah,
same
so
thing. So might
any
as well
one of
write A, B, B, D.
so any one of them is actually I need to know. So suppose K, okay, they are same because so just K,
Correct, correct.
okay, and other than that, A and D is also needed to cover all the 2 by 2 symmetric matrices, right? So A, B, and K, these are independent variables. Okay.
Right, right. Yeah. You mean A, D, and K, delta, not B. Bravo.
A,
Right.
D, yeah, A, D, and K, yes.
Yes, yeah.
Hmm. or how to find the basis. This also explained. Question number 8.
No, question 8 was clear for me. I got all of them correct. Actually, this question, so 7A and 7C, I did not. So is that the answer? Sorry, can you, I was not clear. Can you just clarify that part once again? So you have 3 independent variables, so that's it.
Yeah.
So 2 by 2, no, the symmetric matrices only.
Yeah, option A is actually I should get again. I think I told something else. So here the solution of this matrix. Suppose this is all the x's where ax equal to 0. So what is the what is the x here that satisfies this equation? What is that x?
So that, I mean, that depends on A, right? It will.
No. X. I mean, what are all the x's in Rn where which are satisfying this ax equal to 0? Because A is invertible, so that means this has a unique solution, right?
Right. Yes.
Unique solution, and homogeneous system has unique solution when only 0 0
All
0
of
is
them are 0. But is it
0 0.
mentioned homogeneous?
Yeah, it is mentioned here. See, mention means it is given homogeneous system. See, ax equal to 0 is
Okay,
a,
x equal to 0.
yeah, and A is invertible. That means x is 0 0 0. That's it. So x is 0 0 0. That means the dimension is 0. Okay. I think I told dimension is n. That's why I.
Okay, so my answer to this question was 1. I think my confusion is.
Okay. Understood why. So suppose if it is 1, then
Because 0 0 0 itself, right? Like that has one variable. Like, so if you consider 0 as 1, can't we think of it that way? I mean, for some reason I answered 1. Now I'm unable to exactly express why that came in, but yeah.
So this is a 0 0 0 vector space. This is a 0 vector space.
Right. So that
And
has
0,
one dimension, right? With one, it has one vector in it.
but it is 0, right? Suppose if it is one vector and this is 1 comma 1. Okay. Then we know this is a this line y is equal to x, right?
Yeah.
And it has dimension 1 because it has one vector.
Right.
Okay. And what is
Okay.
this? What is this?
Okay, I got it.
This
It is just a point.
Just a point.
Okay,
So
now I understand why I made that mistake. Okay.
Okay.
Okay, got it. So yeah, the fact that it is just a point. So if it were, let's say, 0 0 1, or I mean any point, right? Any single point on that would still be a. Okay, wait. What if we had 0 0 1? Let's say. That is still a line, right? That is still a 0 0 1 is still a vector.
Yes. So because it is not 0, then it is 1. Dimension is 1.
So that will be one dimension. Okay.
Yes.
Okay. Yes. Okay, I think these are the two, and one more. Sorry, I had 3 errors. So these two were wrong, and of course the last one. So the last question, the value of b.
Or one more thing. If suppose you're telling it is a one vector. Okay. So this is now that's why we cannot make questions, right? Because suppose if you're saying it is a one vector which is non-zero, then it cannot be invertible. See, if it is ax equal to b instead of ax equal to 0, okay, and
Okay.
invertible, then it is not a vector space first. Okay.
I'm sorry, I did not get the intuition.
Yeah.
Can you explain that?
Yeah. I'm telling you. Suppose this ax equal to b, and a is
Right.
invertible. A is invertible.
Right.
Okay. That means it has unique solution which is non-zero, right?
Correct. Yep.
Could be non-zero because ax equal to could be non-zero. Definitely non-zero if b is not equal to 0.
Yeah, it will be non-zero if b is not 0.
It
Yeah.
will be non-zero. If a non-zero vector, so basically this set W1 has only one vector which is non-zero.
Right.
Okay.
So in that case, dimension will be the dimension of that vector only, right?
No. In that case, it is not a vector space.
How is that not a vector space?
Because it is just one vector. One vector cannot cannot be a vector space. Vector space is infinite vectors. Okay. And one more thing, 0 0 is not there. That's why it is not a vector space. Zero vector is not there. Okay.
Okay, in that set we don't have the
Yeah.
zero vector.
That's it. And suppose if it is an infinite, it has infinite solution. Ax equal to
Mhm.
b. Ax equal to b has infinite solution. That means A is not invertible.
Right. Yeah.
In that case,
Correct.
in that case,
So the
what will
second
happen?
condition is
Yeah,
not.
yeah. In that case, still because b is non-zero, that means 0, 0 is not the solution for this, right?
Yeah.
Again, we say because zero vector is not there, then it is not a vector space. But in third case, when this same homogeneous system is given, but it is given that A is not invertible, A is a singular matrix, then what will happen? Determinant is zero. That means it has infinite solutions, right?
Okay.
Infinite solution including zero.
Right. Yeah.
In that case, it will form a vector space, and dimension would be the number of independent variables. Okay, for
Okay.
this system. Okay. Yeah.
Okay. Okay. I think the question, the problem here was with the zero vector. That is the issue that I made. I mean, that is the mistake that I made.
Okay.
And can you explain the last question of this paper?
This eighth.
The very last one.
This one, no.
I think it's asking for the value of b. Not this. Not this. Can you scroll down? Can you keep scrolling?
That's it.
Beyond this, is it not? Oh, okay. Okay. I think you don't have that question with you.
No,
So
no,
the last question.
no. It has all the questions, but maybe shuffled. So if you tell me what is the question?
Okay. Yeah, I'll tell you the question. So the question was, consider the matrix A equals 1, 2, minus 3, minus 2, 1, minus 4, and 1, 0, 1. And the system of linear equations is given Ax equals to 3b1.
Mhm.
Find the value of b if the system has infinitely many solutions. So the answer
Okay.
comes out to be minus 1.
Yeah, this is the question. See.
Right. Yeah. This is the one. It
So
seems they are shuffled.
yeah. So is it related to any question?
No, it's not related. It's independent. So
Okay.
there is one question just before that. It is similar, but it's not related.
Okay. So consider matrix A. Consider system of linear equation Ax equals to b. So yeah. So b is here, and now
Yeah.
it is given that it is infinitely many solution, and what is the value of b? So for this, should I solve
So
this or just give you a hint?
I solved this in the exam. Even I remember. Okay, you can solve it now if you wish to. So I did the augmented matrix. I did all of that. Got 3 questions finally. I equated that to 0. For some reason, I was getting -4 as the answer, and my bad. I was getting 4 as the answer, not -4. I was getting 4 as the answer. I don't know how. So yeah, can you just maybe if you just have the answer from the last step, if you can explain that, that would be enough.
Okay.
Till the simplification of the augmented matrix, I know I got it correct. So that till that part, it was even in the exam I remember getting it correct.
Okay. So you can see this is b, right? And
Yeah.
because it has infinitely many solutions, so two of the row would be same, right? After some manipulation. So
Yes.
so can you just see? Suppose if I take these first two, okay, first two, and I'll just take the second row and minus first one, then I'll get, sorry, plus first
And
one. If I add these two, then I'll get -1, 3, and -7. Okay, no, not this way.
I mean, in one step you can do both, right? Both the second and third rows you can make it 0 in the first column.
What? Repeat.
I mean, yeah. Never mind. You can proceed. I was just saying how I did it in the exam, but it's like within 2 or 3 steps, I think you get zeros for the last one.
Okay.
Anyway, you can continue.
Okay. So I'm just making the third row 0. So I'm just
Yeah.
subtracting. So it will 0, -2, -4, and -2, right?
Yeah.
Yeah. And the all rest of them is same.
So,
-4.
no, wait. Can't you make the second row 0 as well directly? I think that is possible, right? Independently, if you just do second one plus 2 into first one,
Yeah.
then that -2 will become 0.
Yeah. So I'll just 2 times first one and add. So
Right.
this will be 0.
Right.
2 times first one and add is 5. 2 times first one is -6 and add -10. Okay, minus 10. 2 times first one 6 plus b. Okay.
Yes.
Yeah, so yeah, now if we multiply the second row by minus 1, then I'll get minus of this. Okay, and here plus minus. Okay, but what will it will not make any difference. Okay, I have written this one wrong. This is plus. Okay, are you seeing?
Yes. Yes.
Yes.
Yes. So 1 minus minus 3. Yes, that will be plus.
Yeah, that is plus. So now these two are these two would be same after after I divide this by 2. Okay, no, not
Right.
2. Uh, okay, I'm dividing it by 2 first. Okay, then it will be minus 1 and 2, and I dividing it by 5, then it will be minus 1 and 2. Okay, now it is same, right? Is it clear?
Yes.
After dividing it by 5, it is clear. Now these two are same.
Correct. Yeah.
So then because these two are same, so these two are also same. So minus of 6 plus b. Calculation mistake, I guess you have done something. Okay, and this is
Equal to
minus 1.
minus 1.
This is cancel out. So this is 5 minus 6 equals to b.
Yeah, this comes to minus.
Okay.
Okay. So I remember. Okay, I think I might have made another mistake then. So I remember in the augmented matrix, after I simplified everything, I was getting b's in 2 of the rows on the right side of that. So
Still
there were
just
two equations
still
with.
yeah, still just make them equal. If left hand side this side is same.
Mhm.
Okay, any two suppose these here these two rows are same, that means this values are also same for infinite solution. Okay,
Okay.
so this is the only condition. Or
And if I were
one
to.
more, if suppose if you solve further and you get entire row 0 here, entire row 0. Okay,
Yeah.
then here whatever term is here, that will also equal to 0. Okay,
Right. Yeah. Yeah.
okay, that's it.
Yeah. Maybe I'll do it again. I mean, I think
Yeah, yeah,
I understood the mistake. Thank you.
yeah, yeah.
That's all I had. So
Okay,
thank you.
okay, then
By
good
the way,
night all of
okay, Atul, one last question.
you.
So that value that you get, right? Can you go back to that once? If you can go back to one note. Yes. So this minus 6b by 5,
Mm,
instead of equating that with the last row, I mean, whatever that's minus 1, right?
mm.
Uh, it's not correct to equate it to 0, right? Because the other side is not 0. We can't equate that to 0.
No, we have equal to minus 1 because
Both
uh,
the rows are same.
yeah, both the rows are same, that's why. So if we want to equate it to 0, then we will do first one more step. We'll subtract the second row from third, then here
Hmm.
we get the third row will be 0, and here we get and the left hand side we get because it is minus 1, so minus 1 minus of this, so that would be plus 6 plus b divided by 5. Okay,
Yeah.
and rest of the row are same because it is 0 0 0, then we will equate it to 0. Okay, and then
I think this is the mistake I made here. So I got this minus 1 plus 6 by 6 plus 5 by sorry 6 plus b by 5. I think this is what I got in the exam, but for some reason I was getting 4 there. So yeah, I understand the mistake I made.
okay, okay,
But if you put a 4, that you don't get a 0, so that equation itself gets wrong. I understood my mistake. Thanks. I got
okay.
this. Thank you.
So all of you please solve the activities question and practice assignment question and watch the instructor session, then we'll solve questions in next session. Okay, on Saturday. You will leave now. Yeah, good night all of you.
Thank you, sir.
Thank you, sir.